All right, welcome to the next Nix Hour. I just want to announce briefly that next week there won't be a Nix Hour since NixCon is happening and I'll be traveling for that. And then, yeah, but for now, if you have a question and you want to join, please click the meeting link in the YouTube description or, yeah, to join the meeting directly. But yeah, today we don't have anyone here wanting to ask a question for now. So I think I'll go through some issues in the Nix Hour repository that have been opened since last week. So the first one of those, well, I'm just going to pick some of these and go through them hopefully fairly quickly. So we have the finalAttrs pattern. Let's look at the PR here. The question is, what are the benefits of that? Override style recursive attributes. Yeah, and so just brief explanation of what that even is. Oh no, my screen and everything is frozen. This is not good.
I can see you.
Oh. Am I back?
Yes.
Okay. That was very weird. All right, so 24, gonna create a, well, 12.nix, yeah, sure. Make this a bit bigger, import nixpkgs. And then actually let me use another type of syntax today. I'm gonna use channel nixOS nixpkgs unstable. This fetches the latest channel. It's impure, but kind of a nice way to get a recent version. All right, so we do packages, and then the kind of main bit here is std.make derivation. So traditionally, you will see this here, where you just pass an attribute set. So we can pass a name, we can say this is foo, we can say version, and actually if you pass a version, we should use pname instead. Let's use unstable. Let's give it an actual version number, 0.1. 1.0. All right, so this works. We can create a derivation. I'm going to try to nix build that. And then, oh, it doesn't present an absolute path. Oh, I think I need to quote this. Oh, nix packages on channel. Is it? Hold on, channel. That should work. Why does that not work anymore? Is it? Oh, I guess it's actually this. Yeah, we need to fetch tarball. This should work. All right, that was actually fairly quick. But okay, so sources should point to source, but it does create a derivation. Let's just do this for now. Let's try to get it building. No make file, no person. No filter produce output path, so we need to have an install phase, or let's do post install. Just say touch of the output. All right, that works. And so we can imagine we declare this somewhere and say like this is foo, like this, and then later we want to override this. Yeah, and actually, well, let's just do this for now. So let's say we have foo and we want to override this. We can do this using overrideAttrs. This is available on like all the derivations you create using make derivation. So you can say overrideAttrs takes a function and the function receives the old arguments you pass to it. So we can do this. The return value of the function should be the kind of new attributes you want to pass. Okay, and so we can, for example, say post install is actually, let's do first something new. So we say let's do make dir dash, well, make dir. Let's do a make dir here out, and then let's say echo foo to out foo, sure. Then in here, we're gonna add another file at the end. So url.postinstall plus this. And here we're gonna do bar to add bar. All right, we can build this, and let's also cat the result. Oh, not cat the result, we're gonna ls result. All right, we can see 2 files were installed. But you might also want to use this to override the version. And you can do this. Well, actually, you can't do this. So we can maybe see why this doesn't work. So if we try this 2.0 and now do a nix build, or we can also do a nix instantiate. We don't actually need to build it. Actually, that did work. Okay, that was fixed then apparently. So what about pname? Can we also override this? Bar. Yeah, that seems to work. Okay, apparently that was fixed. The kind of main thing I want to show is that these attributes don't always correspond to these, because these are actually the underlying derivation attributes. Let's see. Well, it's a bit hard to demonstrate, but maybe let's not do that for now then. But go back to the finalAttrs overriding pattern. So one of the main things you want to do with the version is to use it to fetch the source. And so in here, let's say we want to fetch the hello source. I'm going to do just let's go to nixpkgs and do a what is the next instantiate eval, let's say -a hello.source.urls. Okay, this is URL where it fetches it from. Maybe let's go into hello. Actually, this is a bit of a draft thing here, but okay, let's copy the source from here. All right. And actually, hello uses the finalAttrs pattern, so we can also see this here. But so traditionally, you would want to refer the version in here. 2.12.1 for now, 2.12.1. Right, so we could do this. So version, we could do this like this. Well, what happens if we don't do this? So if we don't do this, it will say fetch URL is not a variable, fair enough. Will say undefined variable version in here. So it doesn't see this version attribute, and that's just because we haven't introduced it as a variable in the scope. This is just an attribute set definition, and it's not kind of recursive by default. We can do this though with the rec keyword. And so let's try this out. This does work. We get the version, we get the URL correct, hopefully. But now let's see, what if we want to override the version? So version equals, let's say this is 2.12.0. All right. And well, what would we expect to happen or hope to happen is that we get some error because this should have been changed, and then the hash isn't valid anymore or something like this. Actually, this is only an evaluation that, well, it shouldn't fail, but we can try building this as well, and it builds. So it's really kind of hard to detect, but the URL here is still the old one. And actually we can see this using nixinstantiate, or let's use, yeah, nixinstantiate eval. Or let's use nix eval for a change. F default on nix, and then source.urls. Yeah, autocompletion doesn't seem, oh, it does work. Source.urls, and we can see in here the source still uses the 2.12.1. So the rec keyword here, how that works is it creates a very kind of local binding. So if we go into nixREPL and do a rec here, x equals 10 and y equals x, you get just an attribute set as a return value. And at that point, there is no kind of mention of the kind of recursion anymore. You don't have a function in here that you could extend. And so, right, if we do this and we have an attribute set, and then just do something like / and say, well, now x is going to be 11. It's of course not going to update y because we only overrode the x value. If we do want to do that, we need something more clever, and that is, for example, if we go into nixpkgs, or lib specifically, this is kind of where overlays come into play, and kind of fixed points and how you want to extend those. And so we might have a function instead of using this rec here, which is built into the language, we use a function to describe the recursion. And so that kind of works by saying, okay, we get the result as an argument, and then we return what we want the result to be itself. And so we can say x equals 10 and y equals the result dot x. So this way we kind of rely on laziness to make that work, but it's a function where x is a constant and it can evaluate that first, and then y depends on that result. And so we can evaluate this using lib.fix. We're here, I'm already in the lib scope, so we can say fixf, and that gives us back the same thing as before. Now here this would again not work, of course. X equals 11, that would still give us the same thing because this is just an attribute set. But we can use overlays to extend the function. That is done using extends. So extends takes an overlay as first argument, so we can say finalPref here and say x should be equals to 11, and then we pass the function from before, the fixed point function, the recursive function here, and define g using that. G is now another function that we can also call fix on. Now that has the actually updated value. And in the overlay, you can then do a bit more than just changing constant values. You can refer to the previous value. So you can like say, okay, instead of just saying 11, I'm going to say previous.x plus 1. So this way you get the same result, but now if we had, like, let's say f was defined as 0 initially, then we say extend this, then this would again work, and we have the expected result. Yeah, and so I mean, this is what overlays do. And so instead of declaring, well, we are here, instead of using a rec here, which is a language level thing, and this would return the attribute set directly, we're going to use a function instead. And this is what make derivation has recently started supporting. And yeah, so finalAttrs, that's the final. You can also call it final, it doesn't really matter. finalAttrs seems to be the convention. And so we need to make sure to add parentheses around that. And now we can use finalAttrs.version, just like we did before with the function, to do this. And now if we evaluate this again, let's do a nix build of this. Well, I might actually still just try to build it, yeah. But let's see what the URL points to. Oh, it doesn't point to anything. Oh, because that's hello. Yeah, the URL was updated, so that's great. Unfortunately, we have the problem that we didn't update the hash. And so we still need to kind of manually invalidate the hash and make sure the source gets overridden properly. It's actually, in this case, this isn't super useful because here we still need to write to source equals pkgs.fetch-url, and then there's a way to do this, and I think we had this in the previous Nix Hour where you don't need to repeat the entire thing, but it's a bit of a pain. So yeah, source.fetch-url and copy essentially this here. All right, we can use, again, finalAttrs here. And actually, yeah, so this is like, here, what is this old here? So this is the previous attributes. So really, we should call this prev. But now you're kind of wondering, well, how do you get access to the finalAttrs? Actually, let's call this prevAttrs. So actually, that's a kind of new form of overrideAttrs was introduced, where you can also use finalAttrs, and in the same order as the overlays. So you have this form here, same as overlays, where we can refer to finalAttrs, and we can refer to the previous attributes to override them. And so if we try this, well, let's invalidate hash as well. Let's make this a y. And yeah, it tries to download hello version 2.12.0, and I think it failed actually. Maybe there isn't such a version, which is a bit odd, but sure. Let's maybe look at this. Packages, applications, misc, hello. Oh, that doesn't exist. Well, let's try to find a version of hello that does succeed. Master, I'm gonna open hello default.nix, and then I'm gonna do git log patch to get 2.12. Well, 2.12. Why was the version just added here and not? This is a bit weird. Okay, 2.12 apparently. Okay, 2.12. Like this, and next build. And we get a hash, and then we can do that. All right. Yeah. So this is kind of just like overlays in the but for derivation attributes. So yeah. Let's see tangible benefits. So all right. So we showed here kind of that, okay, we can override this version, but it doesn't actually help very much because we still need to do this. And so it's really more useful for other things where you don't have this kind of nested set that you need to provide. So attributes that are directly on make derivation and not ones that require like deeper overrides. And so for example, we could imagine a common thing is actually passthru.tests, where you want to say, well, I want to test the, for example, the version of the package, or you want to say, yeah, we could do like, or maybe it's configurable. Let's look at the testers in nixpkgs. Let's go to the manual and search for testers right here. So, for example, these might be useful. Test equal contents, test build failure, test version, a nixOS test. I guess a nixOS test would be useful. So let's try to do that. nixOS test is the thing, and then we have something like this. We copy that. nixOS test, and then packages.testers.nixOS test, and then something like this. All right, and so in here we might say environment.system_packages equals this one in here, like this very derivation we're defining right now. And we can do this using finalAttrs. Oh, and actually, I think it's finalPackage. This is something a bit special, actually. I think it's finalPackage. Let me just confirm that. finalPackage. Yeah, that looks about right. So I guess here the kind of question is, well, how do you refer to the resulting derivation itself? Because these are just the attributes, but you might want derivation itself. And so I think this is mainly just a convenience feature, because it's actually not part of the attribute sets, but it's just useful to have it. So this is a kind of almost a separate change, but it's also useful. I'm going to comment this out for now. Don't want to make that work because we don't actually have a, well, we do have a working package that is hello. So maybe let's get rid of our custom post installed here. Let's try to make this work. Pass through nixosTests. We want to test this hello here. Let's say this is a custom hello. We do hello test. Nodes, machine 1. What do we need here? System packages. Oh, we had system packages already. And it's actually testing hello. So this is a kind of good example already. So we say environment system packages, finalAttrs.finalPackage. Down here we start all, wait for unit for the service. We don't need that. But yeah, we can just do this. Actually, that should work. Hello, and
You have machine 1 there.
oh yes. Okay, and then we should be able to next build-a tests. Hopefully. Yeah, that seems to be doing stuff. Yeah, okay, let's wait for that. Meanwhile, I think, again, just like a generally useful tip is to just look for examples in nixpkgs. So if we search for finalAttrs, thankfully it has this convention which makes it kind of easy to discover things. So for example here, srb2 finalAttrs. So we see it's used in the version. We see it's used in a separate kind of subderivation. It's used to get the version of the top derivation. And here again, URL. It gets passed to flags. Actually, this shouldn't. No, I guess this is fine. So yeah, sure. exec, you get access to pname, meta.description, yeah, things like that. Yeah, okay, the test apparently succeeded, although the logs are a bit messy, but that's great. All right. I know we have some problem with the Jitsi meeting here. If you have any question about this or any other question you would like to have answered here, now would be a good time. Otherwise, I think let's move on to something else in here. So I think this one might be interesting. What arguments are allowed in for a NixOS configuration? So we can have two arguments, config packages. Later also modulesPath is used. What other arguments can be used in a NixOS configuration? Yeah, this is a bit something else. So yeah, let's try this out. Let's do like a NixOS module. All right, and I think we'll do it like this, where we have a default.nix. So I'm just gonna kind of start off with a simple module system evaluation, and we can kind of see what arguments are available by default, and then gonna build up to a NixOS configuration. So let's do this. Then packages. The main entry point for evaluating the module system is lib.evalModules. This takes modules as an attribute, which is a list, and the list takes the modules you want to evaluate. And so in here, let's pass module.nix as a separate file, such that we can just specify it there. All right, so module.nix, and so let's make a really simple module, just an empty attribute set, and evaluate this. I'm going to do nix instantiate eval-a config. So eval modules returns, actually we should be able to see it here. Right, it returns mainly config, options, extendModules is also useful, but mainly config. That's where the resulting configuration lives. But yeah, so we don't have anything declared yet, so it's just an empty thing. So let's add some options. Let's say foo, create an option. Right, now we'll run into the first problem. Let's also add a type, lib.types.string. So yeah, undefined variable lib. So we need access to lib, and that is one of the arguments that gets provided. So let's do that, and that works. We can also evaluate foo. Oh, the option foo is used but not defined. We don't have a default value, so let's do default equals an empty string. Or let's be a bit more type. Let's do a null or string, and then the default is a null. All right. So what other arguments are there? Let's see. We might have. Okay, let's say we have two options. Options.bar. Another one. I'm just going to copy this one. And bar. We have this, and let's also make this the same type. Let's change this one to an integer. All right, and this one is still a string, and then let's say foo, this is foo string. All right, and then now we want to assign foo string based on foo, which is just the kind of stringified version of the number. We have a question in chat. I'll try to get to that later. So we can do this using config.foo string equals, and then we kind of want to say toString of foo, but we also want to propagate the null value. By default, if you do, let's go into next REPL. If you do toString on null, I believe that just returns an empty string. Yes. So that's not what we want. We can use, there's lib.map nullable, I believe, which does that for us. But yeah, now we have a problem here. Oh, this is, what did I do? Okay. So we have a problem here. Undefined variable foo. How do we get access to the value of the foo one here? I can remove this default. So this is where another argument comes in play. That is config. Config allows you to refer to the final value of the result. So we can say config.foo, and that then works. Let's evaluate foo string. Okay, of course, we propagate null, so the map nullable would work. Let's also remove this just to show that, yeah, this would give an empty string. All right, but let's also say config.foo equals foo. And now we get, oh, right, this should be an integer, 10. Okay, we get the stringified version of that. Okay, another argument, how should we introduce that? We could say something like, okay, this is a bit of a weird use case, but let's say string foo string or int, maybe, and to do that, we're gonna do, actually this would be a bit hard to justify. Let's say, so the third argument is options. And so options allows you to refer to other options, like the full option tree with the types and everything. And for example, we could say, let's add like a debug option. Debug equals lib.make option, and the type, well, let's leave this empty for now. Well, this is not a value type, So the default should be options.foo.definitions. Definitions or files, or I think it's files with, or definitions with locations. I will have to show how you get to this exactly. Types, I guess I'm going to do lib.types.raw. That is a type that doesn't really restrict you in any way or check anything. And let's try evaluate this, debug. Yeah, so that works. We can access, in this case, where the foo option was defined. So in this case, this config.foo value down here, and the value of it, using definitions with locations. What else exists? We can actually fairly easily inspect this here using options. So we previously did config, that's the defined value, and options that's exactly the same options we have up here, and actually config as well. So we can say options, and actually this is kind of hard to inspect, so let's do nixrepl options dot, and so we have all the separate options, including an option kind of tree that gets added by default to all modules. This has things like args, check, and some others. But in here, we can get foo dot, and then we can see here we have definitions with locations. We have highest priority. We have is defined. In a lot of cases, these shouldn't really be used that often. I generally don't recommend using them. But sometimes it's useful, especially for debugging. I've used it a couple times. Sometimes you want to copy the type of another option. This is one way to do it, because you can get access to the type. LOC is where the option is itself. ToString, I think, what if we do ToString on that? Okay, it just prints the option name. So yeah, and I think that is it for the option, the attributes that are available by default. We could also try, what if we do this and just remove the ... So we're going to verify that we have all of them. Oh, specialArgs. Okay, fair enough. There's also specialArgs. specialArgs. So this is kind of a way to access these special arguments, I guess. Let's look into a bit into what that is. So in here, we can use module.args to introduce new arguments at the top here. This is actually also what NixOS does, which is why you have some more in NixOS. But let's say we have a baz and just say this is 20, and then let's say we're going to use baz from up here. Baz, all right, to define foo itself. And now let's do foo string. Unexpected argument, right, ... Right, and so now we can pass baz around in modules and have kind of an easy way to access this. In a lot of cases, I think this is not a good idea to do because these arguments are essentially just an untyped value, which isn't getting checked, and you can't merge it with other values. So it's not composable, and you can easily make mistakes with these or overwrite them in accidental ways. And so I recommend not doing this. My recommendation would be instead to declare an option instead. That's how the module system is kind of intended to be used. So you would say baz is an option, and then you do type equals lib.types.int, then you give it default, that's 20. And so this allows you to change the default. So let's do this. So instead of using baz directly, you have to use config.baz. So you would say config.baz down here, would evaluate to the same thing. But now you can also, like in another module, you could say, well, actually, I don't want baz to be 20. I want it to be, let's use a lib.makeForce. I want it to be 30. And when you do that, it works. And I think actually this does work with the module.args. But for example, if we have a well, this is hard to demonstrate with an integer, but like lines, for example, which would allow you to merge multiple entries together, things like that. Okay, but now specialArgs is when, right, that's the fixed point of the module system, causes infinite recursion if you do things like, so let's revert back to the module.args down here. All right, so like let's say we do an imports now and say, actually baz is a string. Let's say it's down here, let's do this back to 10, and baz is actually a string, which is other module.nix. All right, and now we say import baz. But this will cause an infinite recursion, and so we can't do that, and that's why specialArgs exists. And so this we have to declare outside the module system itself. And so we can do this in here instead, in the eval modules function, specialArgs, let's say baz equals other module.nix. It doesn't exist yet, but I'll get to that. All right, and now instead of using underscore module args, this works, and we get the error that the file doesn't exist. Let's just make this work. Echo this to other module.nix and evaluate this, and it works. Yeah, and so one of the, why does specialArgs exist up here? This is so you can distinguish between the arguments. There are some rare cases where you need to do that, because in this case you don't know whether baz is a special argument or not. And so accessing baz could cause an infinite recursion or not, and you don't really know. But if you can specialArgs can be accessed without infinite recursion. So that's kind of part of it. I think the main use case for this is somewhere in the documentation system, where the documentation needs to reevaluate the entire module system with changed arguments, and the specialArgs should also be in there, something like that. So let's see, did we have everything here? Looks like we have all the arguments here.
Is it just a list of strings of names, or is it an attribute set?
specialArgs should be an attribute set. Yeah, let's use the debug here actually. Default, let's use specialArgs. So yeah, this is a kind of neat way to just expose something from within the module system as well. Config.debug, and yeah, we can see it's an attribute set. Yeah, and so then you get into NixOS, and actually something I should mention here. We have a ... here. That's so you can add more arguments, and the existing modules don't stop working. I used this to check that all the arguments were passed, but this doesn't mean that more couldn't be passed, because you can inspect the function arguments in Nix. So right, you can do builtins.functionArgs, and then if we pass x, and let's say this, you get information about, oh, x is an argument, but it doesn't have a default. And you can also, if it has a default, you get, well, you don't get the default back, you just get back whether it has a default. But yeah, and so you can inspect that and then figure out that, oh, we don't have this argument, so we're not going to pass it. And this is actually exactly what the callPackage function does in nixpkgs. Anyways, so in NixOS you have more arguments, and let's try to get a list of that. How do we do that? We could say, let's say nixos.nix. I'm going to do an import of nixpkgs nixOS. All right, let's say configuration is something, and in here we could do, well, let's print the specialArgs actually. yeah, let's do specialArgs, and then do the same thing from before. Options.debug, make option default equals specialArgs, type equals lib.type.raw, lib, and dot dot dot. All right, and now we should be able to evaluate this nixos.nix file and -a config.debug if this works on the first try. Oh, it does work on the first try. That's neat. modulesPath is a special argument. Okay, so that exists. And modulesPath is, oh, I'm still using channels. This is embarrassing. But yeah, modulesPath is the path to the modules inside NixOS. So this allows you to, this is especially for imports. So modulesPath, and a common thing is, I think, profiles. So you have in NixOS, go here, NixOS modules. You have these profiles, and these are modules that aren't imported by default. And so you can manually import them. So for example, there's like a minimal one, which turns off some features that you might not need for like graphical things. And this could be imported with, that's profiles.minimal. So we could say profiles minimal.nix. All right, and undefined variable modulesPath. Right, we need to add it. Okay, well, evaluation works. We could do a system here. But yeah, others, let's see, we can use config to see others, config.module.args. And can we print it just like this? Hopefully. Okay, this is a bit hard to see, so instead I'm gonna do lib.attr names. All right, that's better. So we have some things here. We have baseModules, we have extraModules, we have modules. And these are, I believe, baseModules are the modules that are added to NixOS by default. So this should be in NixOS modules module list. These are all the modules added by default, and this should be the baseModules. And then we have extraModules. I believe that might be modules added by the user, something like that. Modules, another list of modules. I believe these are all used for documentation, actually, for these rendering the documentation. Let me try to find it. Documentation, Nix, extraModules, yeah, in here. baseModules, extraModules, and this is config.nixos. Well, extraModules, modules, yeah, it's used in here. Okay, so that there is extendModules that allows you to extend the NixOS configuration with extra modules inside the configuration itself and outside, kind of without influencing the main NixOS evaluation. So this is used by the specialization module, actually. So if we go to like search.nixos.org, let's search for NixOS options, specialization. So this allows you to build an additional NixOS configuration. And you also have like a useful inherit parent config where you can say whether it should be like a completely new one or a separate one. And so, right, you could, for example, say right here, Nix settings, course, mix jobs. Right, so in this example, it says, let's build another NixOS configuration where if you boot into that, Nix has like no processors available or something like that. Or actually, no, this is the default, I believe, is using all the processors, but only one job at a time. Yeah, and so actually this will be presented to you at the boot screen. So when you boot up, you can select, do I want to boot into my main configuration or into this separate specialization one? And I think there's even another option, which I can't remember the name of right now. Oh, doesn't seem to be here. Oh, child. I think it's something about child. Child. Well, maybe not. But yeah, so that's that. Let's see, do we have any other interesting ones here? ModuleType. I'm not sure what that is. Those user modules. It also seems related to building. Oh, we have packages, of course. So packages is a NixOS module specific argument. It's not included in the module system by default. And utils, which I believe comes from, like in the nixOS directory, I think there's a lib utils. Yeah, that comes from here. There's some like lib functions for specifically for nixOS in here. I think this should be in lib, personally. But yeah, moduleType. I'm not sure if I want to look into that. Let's make a quick grab. Oh, that's okay. That's moduleType. Yeah, that's also for some recursive evaluation, I believe. Okay, I think that pretty much covers this one. Well, this one, let's not touch on this for now. I want to read the comment here. All right, so the comment is, I'm interested in cross-compiling from Linux to Windows using clang CL. I know there's no Windows headers available in Nix packages. What is the policy for adding unfree packages? How can I handle making the users accept the Microsoft license, or is that something that I will have to keep outside of Nix packages for legal reasons? Oh yeah, that's a great question. So you can do that. So kind of asking users to accept something. And so let's look at some examples. I think, let's see, nixRepl, requireFile is a good one. Let's look at some example, requireFile. So let's look, do I know any? Kobo Redux. Sure. All right, here, yeah. So here it says, okay, we can provide a message saying how users can download something, and then instructions for how people can make Nix aware of that. And so how it works is that you have a fixed output derivation with a hash. So it will look specifically for a very specific file at a specific path. And yeah, once it has that, it can continue the build. But if it doesn't have it, it can't. And so I believe it's implemented just by failing, essentially. Let's look at that. requireFile. File, what does it do? Okay. Yes, it just fails. So it fails if you try to build it, but if you can substitute it or add it to the store directly, it won't fail. And right, we saw the message earlier, how that works. Here it was a nix-prefetch-url. You can also use other ways of adding something to the store. This is a... yeah, actually, I'm not sure why nix-prefetch-url is used here. If you have a local file, you can also just use nix store add or nix store add. Yeah, I think it's nix store add. Yeah, so nix store add. Let's see. Let's try adding lib in here. So yeah, now it just added my lib subtree into the store, and now it's there and can be used by derivations. And so yeah, what happens if we try to build this actually? Kobo Redux, this is also good. We get a warning that it's not free. It doesn't have a free license, so you need to accept it. And I'm going to do this using arg config allow unfree equals true. All right, now it should probably try to build it, but then fail when it inevitably gets to that assets derivation. This is downloading a lot of things. Yeah, here we go. So yeah, you got the message, and users would have to do that. And I believe requireFile is the main way in which this gets achieved. I recommend looking just at examples in here. This will be fairly useful. RequireFile, what does this do? This doesn't give instructions. That's not great. I wouldn't know how to download that myself, but sure.
What if there was a way to obtain it through curl? Like if I could just download it off of the web, like is that something that can be done and be added to like the repo, like through like the instructions, like through fetch-url?
That, I guess, yeah, that should work. So right, the previous example here used nix-prefetch-url. So in this case, it wasn't necessary, but you can also use this for like just URLs that need to be fetched. And nix-prefetch-url will put it in the kind of right. Well, if you have a tarball, you can also pass. Well, I guess, yeah, you could also like say unpack to unpack the tarball.
If it's a more complicated interaction, you might also be able to just inline a variable in the message that is actually a script to download and do the complicated interaction and put it in the Nix store.
Yeah, and you could also, I mean, I guess we are in Nix, we can do reproducible things. And so I guess you can do, yeah, so let's try this. We could try download script in here and say, this is actually write shell script. I think there's also write shell application now or something like that. Let's use this for now. Let's say download and then I believe like this. And then say, right, like curl something, let's say we download the main GitHub page, HTML for now. So we download it and then let's say text equals this, and then nix or nix store dash add, well, curl, then like into a temporary directory or something like that. Let's say foo and then add foo. And then we could just inline this in here and say, please run download script. Like that. And then if we try to build that again, nix build that undefined variable, that's fair. Write shell script. Yeah, so now we get please run this, and then you can just copy paste the store path and it will do the thing for you. And I guess you can also say like echo successfully added to the store. Run the build again. Something like that. And then there's also, let's see, I don't exactly know how to do that, but I believe there's also impureEnvVars, nix curl flags. I believe impureEnvVars maybe. This is a way to pass kind of impure things into derivations, into fixed output derivations. And so you could also maybe make it work where the script says not to run separate command, but you could say run the build again with, let's say, like license key equals something something, and then nix build, where I believe in here you would then have to specify something like impureEnvVars. Well, I don't really know how to do that. It would take some figuring out to do, but this could work. And this is also a way to download private sources that's sometimes used for that. And I believe on Discourse you can also find some examples of this. If I go look for impureEnvVars, how to use impureEnvVars, yeah. Well, yeah. Let's see. We have some more in the chat. Oh yeah, Jan mentioned you can sometimes also get away with deferring it to runtime. For example, instead of packaging something licensed, you can package a script that automatically downloads and builds the licensed file when run. Yeah, that would then of course be not be profiting from the Nix sandbox, which ensures that builds are fairly pure. But that's also doable. Yeah, you can essentially always, and we did this also in this case, where the script itself runs like entirely unsandboxed, and we just output the script in here and then ran it like kind of directly. And at that point, Nix isn't involved anymore, essentially. That's also how update scripts work, by the way. So you have like update.shell, you have all of these update scripts, and all of these also do like queries, curl, and download things. These don't run sandbox. Okay, we have another question. What is the current state of language servers for Nix? Do you use one? Do you advocate for nil or nixd or maybe some other option? I don't use one yet. I heard they're pretty good. I haven't tried them, so I can't really make a recommendation for now. But that would probably be a good topic for a future Nix Hour, actually. So there's nil, and an older one. I think that one is based on, is it Rust or Haskell? Rust. Rust, and then we have the nixd ISP. Yeah, nixp. This is based on just C++ hooking into the Nix code base itself. Alejandra, there's mention of Alejandra in the channel. That's a Nix formatter. And yes, this one is written in Rust. Well, I mean, it shouldn't really matter which language these are written in, but it aims to be very kind of opinionated, and like there's only one right format. But yeah, I can maybe also give a brief update there. I'm on the team, on the Shepherd team for RFC 101, which aims to standardize the Nix formatting. And we're continually making good progress there, and we hope to make that work eventually. So I guess stay tuned for more updates there. Meetings are happening regularly. All right, yeah, we are on time. Thanks for joining, and reminder again, next week there won't be a Nix Hour. The next one will be in 2 weeks. All right, have a good one.